probably the most common way that you will be asked to find domain and range is from a graph. And so when we talk about domain and range of a graph, there are a couple of different ways to represent it. You could use words, which would be just a way to describe verbally to either me or if you're explaining it to somebody what the domain and range of a graph are. You can use symbols, and there are going to be times when you're going to want to use symbols because it'll be a shortcut. And then most often, or always, you can write the domain and range of a graph as an inequality. So we're going to go through instructions for how to do each of these things and then some examples. So when we're looking at a graph instead of a data set, remember a data set is something that has just a list of numbers or a table or just points on a graph. So when we're looking at an actual graph, such as in these examples that we're going to do in a minute, you're going to think about the domain as how far left and right, your graph can go. And that's because your domain, remember, is the set of x values that your graph covers, and x values occur on the horizontal axis. And then your range is how far up and down your graph goes. And that's because, for the same reason that x values are horizontal, your y values, which make up your range, are vertical. All right, so first and foremost, numbers, very important. You are only ever going to list numbers if you have a data set. So capital letters, highlight it, underline it, only used for data sets. So that's what I was talking about earlier, your lists, your tables, and your points on a graph. So only used for data sets. We're not actually going to just list any numbers for these types of graphs. Words are used to verbally describe your graph. So I'm not going to make you write down anywhere that the domain is all real numbers. We have shortcuts for doing that. So used to verbally describe the graph. And then symbols you're going to use kind of at your own discretion. I like to use symbols a lot because they shorten things, and mathematics are mathematicians, are notoriously lazy. So I'm just going to talk about some of these symbols that you might see down here. First of all, I mentioned in a previous video that these fancy brackets, as I like to call them, just mean a set of numbers. So when you use the fancy brackets for domain and range, you're describing all of the numbers that are in the set of numbers, that are in the domain and in the range. This straight bar here, it almost looks like a singular absolute value symbol. This straight bar means, in mathematics, it means such that. X's and Y's, hopefully those are just variables to you, and that's correct. This funky looking E here is actually a Greek letter. It's an epsilon, and it means is in. And then the last one that you might use pretty often would be this fancy R. It's a double struck R, so that basically it looks like this if I write it in actual handwriting. And that's all real numbers, or the real numbers. So if you were going to actually read this domain out loud, you could say the set of x values such that x is in the real numbers. Or down here, if you read the range out loud, the set of y values such that y is in the positive real numbers. So you could get fancier with a plus. There are also other double struck letters for like the integers or whole numbers or natural numbers, but this is pretty much the only one we're going to use for domain and range. So feel free to use this notation for domain and range. Or if you aren't really super comfortable with that, the last thing you can always do for any graph is write the domain and range as an inequality. And so for your domain, it will always look something like this. So you'll have x such that, and then for domain going left and right, you're always going to put your farthest left number here, less than x, less than, and then your farthest right number here. You can always write your domain and range that way. The only other thing you'll have to look out for is you might have to put, oops, excuse me, didn't even change my color there. There we go. You might have to put or equals to symbols underneath here, so we'll worry about that when we get to our examples. And then your range, because your range handles your y values, y such that you're going to put your bottommost number or the lowest number less than y, less than the top number. And again, you might have to worry about or equals to symbols, okay? So if you're not 100% comfortable with writing using these symbols, you can always use an inequality, and it can always be in this form. Please, 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 please make sure that your inequality symbols are always facing this way if you're using this form. I have some students who, for some reason, just like to switch them up unnecessarily. They're always going to be these less than symbols, okay, if you're using that method. All right, so let's go ahead and we'll look at some examples. So in these examples, we're identifying the domain and range of the following graph, or each of the following graphs. So your domain for this one, the first thing I'm going to look at is that, okay, my graph goes all the way. This arrow means I'm going to keep going this way. So as my graph keeps going, I'm just going to keep going this way for forever. There isn't going to be one number that I stop at. So if I'm going to follow my inequality setup that I just presented to you, I do x such that my smallest number, we'll put that number in quotes in your mind, is actually negative infinity, because it's never going to hit any particular number. It's just going to keep going to the left forever. So I have negative infinity, less than x, less than, because remember my inequalities never change. And then my graph goes all the way to the right for forever. So we would say that's to positive infinity. Okay, so that would be an example of the way that you can write the domain. Here, for infinities, you never need or equals to symbols, because you're never actually going to hit infinity. Infinity isn't a number that you can hit. Now, if you were going to write this in symbols instead, I'll do one example of that as well. So if you were feeling lazy and didn't want to practice your infinity symbols, the other thing that you could write for the domain for this one, oops, that's a kind of fancy bracket, x such that x is in the real numbers, because this covers all the way left and all the way right, so that hits all your real numbers. So this is a little bit less writing for those of you who are really gluing on to the mathematician's laziness there. All right, let's go ahead and look at range now. So domain was left and right, so now range is up and down. And so for range, I'm going to look at, if I follow that same inequality symbol, my lowest number that my graph goes to is a -2, less than y, less than. And then the highest my graph goes, well, these arrows mean it just keeps going up for forever, so we would represent that with an infinity. And then I know I can't ever hit infinity, but does my graph actually hit -2? And it does, right? It comes down and it hits that y value of -2. So I actually need an or equals to symbol underneath there. Okay. If you are feeling extra fancy, you can go ahead, and another way you can write this would be y such that y is greater than or equal to -2. But if you're feeling like this is already pretty overwhelming, just stick with the format that we have been using. All right, let's go ahead and try the domain and range of this graph. So for this one, I'm just going to start off x such that the farthest left I go is -5. Less than x, less than. The farthest right I go is 3. And then I have closed circles at both of those points, so I hit both of those. So I'm going to put or equals to symbols underneath them both. And that's the only way you can write it, so it's great. For range, I got to go look at my y values, so up and down. When the lowest my graph goes is -4, so I'm going to do -4, less than y, less than. And then the highest up my graph goes is 6. And then I have closed circles at both those points, so I hit both of those, so it needs or equals to symbols. Awesome. All right, last one we're going to look at, or last two graphs we're going to look at, are these ones, which are a little bit funky, and so I just wanted to touch base with them. For domain, for this graph, I am going to still start off the same way, x, such that the farthest left my graph goes. Now be careful, because some people are going to want to say -3 here, because they're saying, hey, look, my graph stops right there. But you want to look at the very farthest left your entire graph goes. And so I noticed that even if I follow this graph down, it goes a little bit farther left here. So it goes all the way out to -4. So -4 less than x less than. And then the farthest right my graph goes, again, just be careful. It looks like it goes to 2 down here, but if I look at my entirety of my graph, it actually goes all the way out to 3. On the -4, even though there isn't like a filled in point right there, you can tell it hits -4. So we need an or equals 2 symbol. But on the right-hand side, open circles mean you never actually hit that number. So you're going to go ahead and leave that one without an or equals 2 symbol. So that's your domain. Your range for this one, we're going to look low to high. So the lowest, y such that, the lowest number that my graph hits on this entire thing is -5. Less than y, less than, and then the very highest number it hits is +5. And I have open circles at both of those, so I don't need or equals 2 symbols there. All right, this last one looks a little bit tricky just because the graph actually looks so simple. So let's go ahead and do our domain here. So x such that the farthest left my graph goes, well, this arrow means it goes for forever, so I'm going to do -infinity. Less than x, less than. And then the farthest right my graph goes is 1, 2, 3, 4, 5. You can never actually hit -infinity, but you can hit 5. So go ahead and put an or equals 2 symbol underneath there. Another way, if you are wanting to write this with a little bit less work, again, only do this if you feel 100% confident with what we've done so far, would be for your domain x such that x is less than or equal to 5. Okay. For range, now this is where it gets a little bit tricky, but range, you're actually looking at the lowest and the highest way your graph goes. And my graph, the lowest it goes is 0, and the highest it goes is 0. It just actually stays directly at 0. So this is one where you can have a little bit of a anomaly happening. Your y value, no matter what, is just equal to 0. So if you ever have a straight line this way, or if you have a straight vertical line, you are allowed to use an equal symbol in there as well. I will probably be making a video, just an extra one with more examples in it, but after you view this, if you have any questions, please let me know.